Hello, in this one we're going to take a look at some concepts related to conditional probabilities and dice. So we have here the basic faces 1, 2, 3, 4, 5, 6. And imagine we want to answer a question like this one. What's the probability that you get a 2, then you put this vertical bar. So now in this context, that vertical bar represents the phrase given that. For example, you get an even number of dots on the faces. To answer this, what you want to do is just see how many faces have an even number of dots. Let's highlight these. So this has an even number of dots, so does this, and then also so does this. So this represents the reduced sample space. It's reduced because only 3 of these are even and not all 6 of them. Then the next question is, of these 3, how many represent a 2? Well, that is only 1, this one right here. See that? It's only 1 out of the 3, in other words. For that reason, I would answer this question by saying that it's 1 out of 3. So the probability of a 2, given that it's an even number of dots, is 1 out of 3. Let's do another one, but imagine this time you want this probability. Probability that it's a 5 dots, given that the number of dots, I'll say that here by saying number of dots is, say, greater than or equal to 3. That's our question. So the probability of a 5, given that the number of dots is greater than or equal to 3. So first, let's mark the reduced sample space. The sample space, which is that the number of dots is 3 or more. That means this one, this one, this one, and this one. The 1 and the 2 are excluded because they don't satisfy this part right here. The next part is, how do you take care of the 5? The 5 corresponds to the one that has 5 dots. Well, there's only one of them, this one right here. See this? So this tells you that the probability is equal to simply 1 out of 4. So probability of a 5, given that the number of dots is greater than or equal to 3, is 1 out of 4. First, you mark the reduced sample space, for example, and then you count out of that new sample space of only 4. Here's another one, perhaps a bit more involved. Imagine that we want the probability that what you get basically is a 1 or a 2, given that, for example, the number of dots is less than or equal to, say, 3. That's our goal here. So you want to mark up the reduced sample space. In other words, you want to take care of this part first. So number of dots less than or equal to 3 means it's the first one, the second one, and the third one only. Then after that, it says we want a 1 or a 2. That would correspond to this one or to the 2. So as you can see, just by counting, that would be basically 2 out of 3 for that reason. So 3, number of dots less than or equal to 3, and then only 2 of those have a 1 or a 2, so 2/3. So these are some of the underlying concepts behind conditional probabilities. You have a reduced sample space, and then you calculate a probability based on that smaller sample space. Thanks so much for watching.